First of all, okay, I have turned on my video so that you can first see me. And after that, in meal time, I may switch off the video because everybody might have network issues. So if I can switch off the video, then there won't be any interruptions due to the network. Okay, so first of all, thank you everybody for having believe in us and joining the demo sessions. And suppose if I speak with, actually for me, I have did my masters in IIT Guwahati in the year 2014. And after that, right now, after that, in the span of 5 years, I have worked in different institutes and I have teach so many subjects like mostly my background is around structures, so mechanics, strength of materials, analysis. In addition to that, I took another subjects like mostly geotechnical engineering, foundation engineering, and survey too. So most probably for you, I'm going to teach you structural analysis and geotechnical engineering and foundation engineering. And right now, I'm just working on a project that is in relation with the IIT Kharagpur. Okay, that is my credential as of now. So I don't think I will be discussing much topics. Are I will not stick to a specific topic in this demo session. So before that, before going to start any like structural analysis subject or engineering mechanics or even any strength of materials, what do you think the most common value that you guys have found as of now? Like while either you're doing in mechanics or strength of materials or analysis. So what is the most value that you have found? Or let's just be take it question simply that which subject, like whether you guys feel this analysis topic, how many of you feel it was easy or difficult? I think most of you guys might find it's difficult just because, unlike in other subjects, on this subject, we don't have to by heart any formulas, nothing. Only the thing is that here on this subject, we have to understand the topic, like then only we can apply it on the like any other problem instead of by hearting a simple formula like the other subjects. So before going to before going to teach mechanics or something, what I will do to the students is just I will check their fundamental basics. There is means we all know about the force and also we all know about the moment, right? So suppose if I simply ask you what is mean by a force, or if I simply ask you what is mean by a moment, can you guys anybody respond? Or can you define how to find a force or how to find a moment and what is the unit? Yeah, feel free to express your thoughts. Okay, it's nothing like we are not going to judge anybody. So feel free to respond. Always, we are here to learn everything. Either in chat box or through audio, you guys can express simply what you know about movement and the force, or you can express their units too. Yeah, I think I have received one response. Yeah, it can be used to move or stop a body. Okay, thank you. That's right. Yeah, F equal to MA, Newton unit, fine. And coming to the moment, force into perpendicular distance, yeah, that is absolutely correct. Okay, I think everybody knows this, right? You can think of why we are discussing about these moments and force. Now, can you go back, or if you can recollect whether mechanics course or if you guys completed strength of material or if you guys have completed analysis, can you recollect briefly? Mostly you have done, or you are going to find, either you have to find the net force or you have to find the net moment, or mostly if you are taking a problem, more or like the entire problem is consist of around 50% is finding these forces and movements only. So what I will say to students is that if you can able to find forces and movements correctly, then you have did 50% of the questions correctly. But where the problems we are facing, right? So before going to do that, let me just show you a simple problem. So this is I have taken from one of the reference. So here on this, as you can see in the picture, so here you have to find out the movement with respect to the point O because of the force that is acting 120 lb. Lb is nothing but a, we will not use in our Indian, so that represents the pound. So can we simply find the moment at point O on this problem? So take me guarantee that if I give this problem to 10 of the graduated students, then I can say that hardly one or two can solve it. Do you guys believe me or not? I did the same experiment to other institute students. So whatever I'll do, this is my initial problem that I'll give to every batch, and I'll ask them to find the moment at point O. Why? Because if you guys can find this problem, then I can say that you can do well in the analysis course. Why? Because it's mainly consists of finding the moments and the forces only. You may think it's silly, but if you go and recollect whatever you have done, then definitely you are going to believe this. Okay. So on today, I don't think we can solve this problem, but just the glance I can show you, because here I have shown you the complexity in finding the moment. In most of the problems that we may encounter may not have this much complexity. Why? Because what are the exams they will ask you? If they ask you the 3D problem, then 30 minutes are gone for that problem only. So it's obvious that in exams, we cannot expect these 3D types of questions unless and otherwise there is very basic fundamental problem. So here, so let me just with the force or movement. As you guys know about force or movement, so I can simply say that the force either it can be measured either in newtons, or if I add some prefixes or suffixes, I can express it in kilonewtons, meganewtons, and all. And one more point, whatever the value, not only whether, not only from here, whatever from now onwards, whatever you're going to do, always remember that unit plays a major role in the competitive exams. So if you make habit of writing unit, then I can guarantee that you may not commit a mistakes in the competitive exams. Or if you're if you are well equipped with the units, then I can say that one or two problems, whatever the exam you take, either you take GATE exam or you take IAS exam or you take any state PSC exam, if you can understand the unit well, then at least I can guarantee that one or two problems can be solved. So that's what's the major role that unit plays in the competitive exams, because there will be very big question in the GATE exam, somewhere in the brackets they will ask you to express the value in the newton. But do you know, in the answers you will have 1000 newtons, and in the answer you will have 10,000. So just like that, you will have the answers in the multiples of kilonewton. Suppose if I express this in kilonewton, I can express this as a 1 kilonewton. If I express this in meganewton, I can express it as a 10 to the power of minus 3. Here they don't give you the unit, but As you can observe here, then let us say there are only three options, A, B, C. This is also correct option if I express it in units. This is also correct option if I express it in kilonewton. This is also correct option if I express it in meganewton. So if you don't see the unit, then if you're expressing 10 power minus 3, it is wrong. If you're expressing 1, that is wrong. 1000 only the correct answer. So this is where the students will use it to commit the mistakes. I have seen most number of the students are committing mistakes here only. Ultimately, they'll get the correct answer, but as because of they are not concentrating on the unit, they are going to lose either 2 marks or sometimes they may get the negative marking too. So from not only here, whether wherever you go, from now onwards, just make a habit that you try to write down the unit on whatever the value you will mention. Because as once again, that plays a major role in the competitive exams. And the next, if we come to the moment, then as you know that we can see it as a force into perpendicular distance, right? So just like here, I can express this in terms of either Newton meter, kilonewton meter. So it's upon the problem. We can express it in terms n number of problems. So these two, I can say, they plays a major role in any problem. So why it in any problem? Ultimately, what you are going to, if you remember, you are going to find the summation of the forces, or you have to find the summation of the moments. Summation of the moments means like it's not like you will have only one force and you have to find out only one moment. Depending upon the requirement, there will be n number of forces, and depending upon the problem, you have to find the n number of moments. So what you just have to do, like it's not a direction, like just go straight, take right, and take left. Those we can say we can express through words, but here if you have to find the algebraic value, then what we have to do? We have to add them according to their directions. That means if there is any force, as you all know that if it is acting on the right side 100 newtons, or there is some force it is acting on the left side 50 newtons, then you can express that what is the net force acting on that object. Simply if I can say that, you will say that there will be net force 50 newtons that is acting on the right side. This you can simply visualize it. Or if you are having 10 forces, 15 forces, then obviously what we have to do? You have to assume a direction, right? That initially you have to assume that if it is acting on the right side, you will assume it as a positive. If it is acting on the left side, you have to assume it as a negative. First, suppose that if you are speaking about along x-axis, let us say, and there is one more point that it doesn't matter on which side you will consider positive or negative. It's up to you. But you have to remember that sign. That means here what I'm doing, I am considering that if any force is acting on the right side, then I am considering it as a positive sign. So if I any value, if I express any value in terms of plus 100 Newton, or simply if I express it as a 90 Newton, here I can say that I am referring to the positive sign. That means I am representing the direction with signs. Why? Because if I use the direction right side, left side on every force, it will be difficult for me to find the algebraic value. That's why in structural analysis or whatever the problem you do, as these are the vectors, these are having some direction. So instead of always saying 100 right side, 90 left side or so, what you have to do? You have to represent with the sign. That means if I say plus 100, I am simply saying that my force acting at a point is 100 Newton, and what its direction? This direction is acting on the right side. Similarly, if I say it is a minus 90, minus represents the direction. So 90 is the magnitude. What is the direction? direction is acting on the left side. For forces, it is fine. It's well good that as of now we have seen uh, left side or right side. But coming to the moment, as we know that force into perpendicular distance and unit will be Newton meter or something. How we will measure the moment? Suppose let us say that simply, just for the simplicity, what I'm taking. Hope you guys can tell me this answer. So even though it is not exactly straight, let us imagine it is straight. So let us assume that there is a force acting on here, 10 newtons, and the distance between to the point O to the point A is 3 meters. And let us assume that this is the two-dimensional problem, and let us assume that that two-dimensional plane represents along the direction y and the direction z. Okay, now can you guys tell me what is the moment at point A, and also can you guys tell me what is the moment at point O? Hope I think you can freely express this value. We might have seen a number of times. So can you just quickly tell me what is the moment at point A and what is the moment at point O? Yeah, Mituraj is correct. Moment at point A is 0, and the moment at point O. Yeah, at point O, it's 30. Like as we have spoke at the starting that, yeah, that's must and should. That 30 Newton meter, right? Unit is must and should. And still, uh, to be exact moment at point O, something is missing. Can somebody tell me what it is? Moment at point O, 30 Newton meter, but still some lack of information you are providing on this problem. What is that quantity that you are missing at point O? Yeah, 30 Newton meter is nothing but a magnitude. What about its direction? Just like Sharanya told, it's like clockwise. Yeah, it's clockwise direction, the moment at point O. Suppose, as we have discussed, that if I assume my clockwise movements are correct, then I can express this as a my clockwise movements are positive, then I can express this as a plus 30 Newton meter by avoiding this sign. Okay. So here you have did this in the form of like you have taken force 10 and you have taken multiplied by 3, right? That's fine. What is the direction? Okay, that's clockwise. On which plane? Suppose if you are talking about the force here, can you please tell me that is acting on which direction? As you can see here, the force is acting along the z direction, right? So just like here, what is the moment that is acting here? On which plane or on which direction that you are referring to? That plays again a major important role in the analysis part. It's about finding the exact value. It's about representing the movement. It's about representing the direction. And also it's about representing on which plane it is acting. So it's correct that moment at point O is 13 Newton meter clockwise direction, but still one more point you are missing. On which plane or on which direction this moment is acting? Can you see any response? Is it acting along Y? Is it acting along Z? Just think about it. So, okay, let's forget. Yeah, I think we have received. Yeah, I think Angel Christie is saying that it is acting about why. So, okay, before moving on to this problem, I think hope you guys have heard about the equilibrium equations, isn't it? So, what are the equilibrium equations that you have heard? Yeah, it's fine. Let me going to explain that. What is the equilibrium equations? Mostly you guys have heard. You might have heard about summation of x equal to 0, or you have heard about summation of y equal to 0, or you have heard about summation of moment about z is equal to 0. I think whatever the book you have seen, so these are the equilibrium equations for the two-dimensional object. If I remember exactly, or what they'll say you, summation of h is equal to 0, summation of v is equal to 0, or they will say you that summation of m is equal to 0. See here, forces about x, forces about y. Here, see, movement about z. So imagine, right? I think I don't know whether you guys have seeing this class through phone or through laptop. Imagine that uh, you are seeing through this phone. Let us imagine this is your phone size. You are seeing through video, and imagine that this is your axis y and this is your axis z. You try to rotate this phone. You are going to rotate like this, or you can rotate in any direction. That means if you imagine that you are rotating your phone that you are holding, that means you can observe that your both axis y and z, they both are rotating. If you are speaking about the movement, or if you are speaking about the rotation, that means the rotation or movement that is happening over the entire plane. So here the entire plane will rotate. That rotation will always, we will express that in terms of the perpendicular axis. So what is the perpendicular axis for this y and z? That we can say it is a x. I think hope you guys might have remembered the right hand thumb rule. Imagine that keep your hand perpendicular to your phone to yz. So whatever your right thumb represents, that is what nothing but your another direction. So here I can say that my movement at point O, that is acting along which direction? What is the perpendicular axis to this both? Always x. So movement about point O on which direction? Along x. And what is that value? 30 Newton meter, right? So, or let us come simply understand this problem. I think, hope you guys know the cross product, right? Let us say that if I am having the cross product of two vectors, let us say, I think everybody remember this. Along x we represent with I, along y we will represent with j, and along z we will represent with k. Can you guys tell me what is I cross I? Or can you tell me what is I cross j? Or can you tell me what is I cross k? Do you guys remember? What is the I cross I? Cross product of I and I. What is I cross if I multiply with cross product of unit vectors I and j? What is the cross product of unit vectors I and k? Hope you might have remembered, right? Just if you can recollect it, what is this value? Cross product. What is the cross product of this? And what is the cross product of this? Yeah, Deepa is saying that the cross product is 0. Yeah, you're absolutely correct. Suppose if I speak with Ij, I can say that what is the perpendicular unit vector corresponding to I and j? K. And here I can say it is j. Let us forget about as of now about the magnet, whether it is positive or negative. So if you are finding the moment is also a vector, isn't it? If I want to find out the moment, then what I can do? What I will do is that I will do the cross product of force vector times the position vector, you can say, or you can say any other like own term you can use it about r. That means if I am talking about point O, I'll find out the position vector of point O with respect to the point of action of force. So if here it is a simple problem, here we can directly know that force is along y direction, and the distance, if I represent it as a r, distance is along the, sorry, force is along the z direction, distance is along the y direction. So what is the perpendicular direction to this both? That is nothing but x. So here your movement is acting along the x direction. So here it is a simple problem, so we can visualize it. But what if it is a complicated problem, just like we have shown here? So in this problem, we cannot simply visualize. So why? Because here the force, if you are seeing the force here, see here, this is not either aligning with z or not aligning with y, or it is not aligning with x. Or if you are talking about the position vector for the point B and the point O, again this direction, it is either not lying along x, not lying along y, not lying along z. So if they are simply lying along the x, y, z, then we can simply find out the direction of the movement. Just like here, we have seen that the force is along the z direction and the distance is along the y direction. So by this, you can tell that the movement is along the x direction. But so every problem, it is not as simple as that we have seen. So if you are feeling difficulty in finding the magnitude or in finding the direction, just remember, I think you can, I definitely hope that you guys know how to find the cross product. So based on the cross product, you can find it out. Suppose if I'm having the force, suppose if I take the same problem here, so what is the problem we have considered here? There is a cantilever beam, point load acting here. As far I remember, it is 10 newtons, and here the distance expressed as a, right? So what is my force vector? How I can represent it here? So here there is no force along x direction. So simply I can represent it as a 0x or 0 I bar plus there is no force along y direction. What are the directions we have considered? This is the direction y and this is the direction z. So again, there is no force along y. So I can say 0 z bar. And if I see this 10 Newton, see, I am seeing my reference axis z. It is acting about upside, upward direction. But here, as you can see, whatever the force I am giving, that is acting in the downward direction. So whatever the force that is acting opposite to the direction of what I have mentioned. So as it is opposite to that, what you have to take here, you have to take a negative sign, 10 k bar. So this is how you have to represent your force vector. And similarly, if I want to find out the position vector, let us say that I am going to find the position vector between the points O and A. That means you can see what is the distance between the point O and point A. So the distance is that is truly lying along the axis y. So there is no distance along x. So I can say it as a 0 I bar. And coming to the y, if you are talking about this is your initial point, then from this point, whatever the distance to the point A, that is acting along the given direction. So here I can say that plus 3, y represents the j. And there is no distance along z. So I can say this as a 0 k bar. So these are your position vectors. Now, how do we guys express a cross product? So how do we express modulus? If you guys remember, here we will say I bar, and here we will say j bar, and here we will say k bar for the force. Along I, 0, along j, it is 0, and along k, what is this? It is minus 10. Similarly, for the position vector, along I, it is 0, and along j, it is nothing but a 3, and along k, it is 0. So from here, I think you guys can find out, you can say I bar times something. If you remember, minus j bar times. So 0, 0, 0, 0, so just like everything gets cancelled, then in the final, this one will be I bar 0, k bar will be 0, and you can see sorry, there is some technical issues. So just like here, if it is directly given, then we can find out or we can visualize easily along which direction they are acting. Otherwise, we can, if it is a complex problem, what we have to do, you can think of in the form of vector quantities. So if you can think of the vector quantities, then you can find out the direction on which it is acting very easily. Okay. So so this is how we are going to find out. So at the starting, imagine that always think about with respect to the mathematical quantities. So if you express in terms of mathematical quantities, then at the starting, the things you may feel is difficult. But if the problem comes difficulty, then there you can able to give your 100% your concepts. Thereby, you can't commit any mistakes. Okay. Now, so that is what about the forces and the moments that you are going to find it out. Now, let us see. Let us talk about the equilibrium equations. So before going to do that, let us suggest for the simplicity. Let us imagine I am talking about the two-dimensional plane. So you can see equilibrium equations, equilibrium. Just try to understand the meaning of that. Equilibrium, equal, equilibrium, stable, neutral. If I talk about the synonyms, that means either you speak with respect to the point or you speak with respect to the body. That should be neutral or stable with respect to what? With respect to the forces or movements acting on them. So if you are talking about any point in a structure, or if you are talking about the entire structure, that should be stable, right? Because of the forces subjected on them. What happens if they are not stable? Imagine that. So at one time, you have constructed a structure here, then because of the forces acting them, imagine that in the next morning you have woke up, the structure has moved here. Do you think that is going to happen? So this is what extremely I'm saying about it, but still, what I can say that if any object is moving, so what I can say here, I'm talking about the rigid body motion. So if the body is going to subjected to rigid body motion, that means simply I can say that imagine you are skating. So how you can imagine skating? So if I'm having skating boards, imagine that if I'm having some roller points here, if I push somebody, what will happen? This will easily move. That means what's going to happen? That's the position of the structure is going to change. So wherever you are going to construct, that means this is what I'm exaggerating the situation just to let you understand the things. So whatever the object you are going to construct or structure, that should be stable. That should be there itself during its life period. So how we can make sure that the position will be stable? Either you talk about RAS or any type of the structure. So for that, how can we make it balance? So before going on to understand that, so first of all, you have to understand what is the physics behind that. So just for the simplicity, let us imagine, okay, let us imagine I am considering a plane that is acting along X and Y. Okay, let's just imagine that I have taken a piece of rectangular object. Okay, so can you guys tell me in how many directions this piece of object can move? Imagine that you can place a rubber or you can place anything on something on your phone or on the table, or you can imagine what are the possible ways that that object can move. So if I take, if I imagine this is my piece of object, then can you guys tell me in how many ways it can move? If you remember or if you can understand this object, either it can move along X direction or it can move along the Y direction, any other possible direction in other than this X and Y. Or can but somebody tell me why it can move along X and Y? Why can't this move along this direction? Why I'm not considering this? Why I will always speak along X and Y? Because imagine that the distance here is 3, the distance here is 4. Imagine the distance here is 5. Imagine if I know 3 and 4, don't you think I can find this distance? That means another root 3 square plus 4 square. So why? Because is every textbook is always speaking about X and Y, or it's always about speaking about YZ or something, just because if you know along X and Y, then you can find out the direction or distance moved by the object on any direction. So always we will speak about the reference axis such that we can find out the distance on any direction. So here I'll simply tell you the direction of this object. Either it can move along X or it can move along Y. If it is moving in any direction, still I can express that in terms of the X and Y only. In any other direction, this can move only X and Y. There is one more thing that you guys have to think of. Instead of moving X and Y, imagine you can rotate it, right? So the rotation can also happen. So if you are considering any two-dimensional object, then if you are considering any object, in how many directions there is a possibility that object can move. If I speak with respect to the displacements, imagine the object can move either along X, the object can move either along Y, or I can say that it can rotate. Imagine the rotation I can express in terms of the theta. Here, if I represent the direction, how can I represent perpendicular to this plane? Here, the perpendicular to the planes X and Y are Z. So if I take any object, either it can move along X direction, it can move along Y, or it can rotate. So what we are now dealing with, we have to make sure that, or if the structure to be stable, think of how can I make it stable. Imagine if you apply force, then what will happen? The object can move. I don't want to move it. Then Imagine that there is an object. Imagine that I am applying some force of, let us say, 100 Newton. Think of it. If I apply 100 Newton, obviously what will happen? That object can move along the direction of the force, right? But what I'm interested in, I am interested in that object, even though I am applying the 100 Newton force, the object should there itself. How can I make sure that object will not move? Or in contrary to that, what I will do, so if somebody is applying 100 Newton force on the direction, what I will do? I will apply the same 100 in the opposite direction. Then what will happen? Plus and minus. Then what is the resultant force acting on the object? Zero. Or you can imagine, right? So just like the same way, you can think of in this direction. I don't want my object to move along X direction. Then how can I make sure that my object will be stable? By imposing some conditions. What is that condition that I can impose on X such that it cannot displace along the X direction? So what is that condition here? Just like you can see here, plus 100. So if I express that in terms of the equation, then how can I express it? I can express it as a summation of the forces along X direction is equal to 0. Here I am simply showing you only two forces. Imagine if there is object here, if there are n number of forces acting like this. So here it is easy to visualize, but is it easy to visualize here? No. That's why here we are imposing a condition that the summation of the forces along X is equal to 0. Similarly, if I want to make sure that my structure should not have any displacements along y direction, then how can I make sure? That I can make sure by imposing a condition that my summation of forces along y is equal to 0. Similarly, if you apply the force, displacement will happen. If I apply the moments, rotation, moments will cause the rotations. So if I don't want any rotation, then what should I do? I can make sure that my summation of the moments along z directions will be equal to 0. So this is how the equilibrium equations came up. If you can make sure that the forces along x and y are 0, then whatever the direction you resolve these forces, the net value you will get it will be 0. Why? Because along x 0, along y 0, you take any plane, what about the net value? It will become 0 only. So if your structure to be stable, or if your structure to be equilibrium position, then to make sure that going to happen, then we have to make sure that your forces, summation of forces and summation of moments will be is equal to 0. So this is what in general we have spoke about the two-dimensional object. Now let us imagine that I am talking about a three-dimensional plane. Let us imagine x, let us imagine y, let us imagine z. Imagine you have taken a stone in, like in reality everything in the three-dimensional space only. There is nothing in the two-dimensional place. Imagine that I have taken a stone. Now you can think of, just like in the same case, if I want to express my equilibrium equations. So first of all, I should see that in which direction that object can going to displace or rotate. So just like in the same, if I take any object in the three dimension, imagine you are taking a stone in reality. So can you tell me in how many directions you can move it? Just like in the same way, you can move the object along x direction. You can move that object along y direction. You can move that object along the z direction. In addition to the displacements, what you can do, you can apply the rotations as well. The object can rotate along the x direction. Similarly, the object can rotate along y direction. Similarly, the object can rotate along the z direction. So, how many possible displacement positions are there if I am considering the three-dimensional object? How many are there? There are total six. Now, what is our main aim? Our main aim is to make sure that the structure should not be going to rigid body displacements. Then how can I make sure that let it happen in the three-dimensional case? I have to make sure that all these six components will be equal to 0. How can I make them equal to 0? By imposing some condition. What are those conditions? So to impose this restriction, then what should I do? I should impose that my summation of forces along the direction will be 0. Similarly, if I want to impose this, what we can do? We can impose it, the summation of forces along y equal to 0. Similarly, if I want to impose this, what we can do? We can impose this summation of forces along z equal to 0. Similarly, if I want to impose rotations, if I want to impose restrictions here, what you can do? I have to make sure that my summation of the moments along x will be equal to 0. Similarly, here, I'll make sure that my summation of the moments along y equal to 0. Similarly, here, I'll make sure that my summation of the moments along z is equal to 0. So now you can, as of now, you can visualize that if you are talking about in general a three-dimensional object, so how many equilibrium equations you can have? So if your structure to be in equilibrium, then it is must that these six conditions should satisfy. Similarly, if I am having any two-dimensional object, then if the object to be in a stable condition, that means if the object is not going to have rigid body displacements, then how many equations they should satisfy? They have to satisfy the three equilibrium equations. So if you are having any two-dimensional structure, it is must that these three conditions should satisfy. They're already in your hand. If you are solving the three-dimensional object, that means these six conditions, they has to satisfy. Okay, now let me introduce another topic, that is, let us say that if I'm having two unknowns, x and y. So to get these values, can you guys tell me how many equations I should have? Imagine that I'm having the unknowns as x and y. If I want to find out these two, how many equations I should have? No, I'm having only unknowns as two. I'm having unknown x and also I'm having unknown y. How many equations? I'm having two unknowns. That means to solve these two unknowns, I will need two equations. That means if I'm having two unknowns, I can solve them by using the two equations. If I'm having five unknowns, I should need five equations. Similarly, if you can see here, if I'm talking about the two-dimensional object, how many unknowns I have? Sorry, how many equations I have? Three equations that are already there in my hand. Why? Because whatever the structure we are going to construct, that should be stable. To make sure that's stable, these three conditions should satisfy. That means on my hand, I am having three equations. That means if I am having three equations in my hand, how many unknowns I can solve it? I can solve three unknowns by using three equations. So, if you are solving the two-dimensional problems, if you are having three unknowns, those three unknowns you can solve it by using the three equilibrium equations that are already there in your hand. So, if you are talking about the two-dimensional structure, now I am introducing the new term, that is determinate or indeterminate. So, if you are having the two-dimensional problem, if you are having three unknowns, those three unknowns can be solved by imposing the conditions of equilibrium equations. That means these three can be solved by using these three equilibrium equations. No other extra conditions you have to provide. So these three unknowns, as I can solve by using these three equations, then I can term it as a determinate. That means whatever the unknowns I have, those I can solve it by using the equilibrium equations. Similarly, if I'm having the three-dimensional object, can you tell me how many unknowns I can solve it? As I'm having the six equations, I can solve the six unknowns. That means if I am having the two-dimensional object, three unknowns I can solve it by using the equilibrium equations 3. If I am having the six unknowns, those six can be solved by using the equilibrium equations of six equations. So for 2D, up three unknowns we can solve it by using equilibrium equations. For 3D, six unknowns can be solved by using the six equilibrium equations. So now, if you are having three unknowns for 2D, six unknowns for 3D, those will be termed as a determinate structure. Why determinate? Determinate, the term itself we can understand. That means you can be find out. Indeterminate, that means these equilibrium equations will not suffice for finding the unknown. That means if I'm having the four unknowns for 2D structure, but how many equations I have? Sorry. So if I'm having the two-dimensional object, just a second, a network glitch. If I'm talking about two-dimensional object, okay, then it's fine. I think, yeah. So if it is a two-dimensional object, if I'm having four unknowns, three I can find out by using equilibrium equations. Then whatever the remaining, that remaining we have to find out by imposing the another condition. What is that condition might be? That condition will vary depending upon the type of the structure you are going to analyze it. So those extra equations will be based on the structures you are going to analyze. So that's why those will be called it as a indeterminate. Okay, now as of now we have seen about the basics about forces and moments, and also we have seen about in a vector notation how we can find it out, and we have seen how to impose the equilibrium equations, and also we have seen a brief introduction on the determinate and indeterminate structures. So if you have any doubts you can ask me, otherwise thank you for participating in the demo session, and we hope to forward to looking to you all. Thank you. If you have any queries you can let me know.